Electronic Homework 1.0, number 9. So someone asked about this one, so I'll do it out and post it for everybody. Get a collection that way. So the directions say to write your answer with positive exponents only. So we need to simplify everything down using our exponent laws. And if you don't have those memorized, I will post those, a sheet for you to memorize those easily. If you kind of rusty on that. So first thing I would do with this one is I would apply the product to power rule here in this piece. So I end up with x cubed. In the example they had dots in for multiplication, but you don't really need them. So I'm going to get rid of those. So x cubed, and then y to the 6th to the 4th would be y to the negative 24th. And then we have z to the negative 5 times 4 would be negative 20. So we multiply the exponents when we're raising up. On the next thing I'll do is the denominator, if there were anything to do, but there isn't yet, so I'm just going to rewrite it. And I can actually get rid of these parentheses now because I applied my power rule. I wouldn't ever distribute this multiplier here over multiplication. We don't do that. We only distribute when there's pluses or minuses in there. Sometimes people want to take in, even at this stage here, I'll put those back. They're tempted to want to go x cubed times the y to the negative 4th, and then x cubed times the z to the negative 20. We wouldn't do that. And the reason is because, just as an aside, if you had 2 times 3 times, like 1, for example, we'll keep it really simple. This would be equal to 2 times 3 if I did inside the parentheses first, and then I would get 6. You could also just do 2 times 3 is 6 times 1, and you would also get 6. But if you went 2 times 3 is 6, and then 2 times 1 is 2, and tried to then multiply those together or add them or something, it would not come out to be the same thing. So we only distribute over pluses or minuses, okay? So just keep that in mind. Don't try to do anything more with it. So we can just remove our parentheses here. And now we can simplify. And our rule for division of monomials for this one, we are going to first just look at the x's. So I would take, and sometimes it's just easier to write it like this, I'm going to subtract the exponents. So I keep my base, and then I do 3 minus 4. Now I'm going to look at this next one here. Okay, and I'm going to keep my base. I'll write that in this color here. Y to the negative 24 minus 7. I subtract the exponents. The last one, z, I'm going to keep my base. And then I'm going to subtract my exponents, negative 20 minus negative 8. So be careful there. Now I just go ahead and simplify those. So x to the 3 minus 4 is x to the negative 1. Y to the negative 24 minus 7 is going to be y to the negative 31. And then we end up with z, match my colors here, z to the negative 20 minus 8 is going to give me a plus there, right? So I would have negative 12 is my power on the z. Now these are all to the negative power, so we do have the rule that says if I have, I'll just pick n to the negative m, that would be 1 over n to the positive m. Okay, so we need to just put those underneath. So in our final answer, we will have 1 over x to the first, y to the 31st, and z to the 12th. Okay, and that would be fully simplified. So I hope you found that helpful. Do look up your exponent laws if it's tricky. We will do more with that when we hit the exponent unit, but this is just kind of refreshing. The rule I used right here was called the product to power rule, so I'll write that one in there for you. And how that one goes is usually it's like a to the m, b to the n, all raised up to like whatever we could call it, you know, even q or something like that. And we would just do a to the mq and b to the nq. We multiply the exponents when we're raising up. Okay, if we have something like a to the n times a to the m, so I have like bases and I'm multiplying those two together rather than raising up, that's where I just keep the base and I multiply the add the exponents, n plus m. Okay, so it's kind of one step down. What you do with the exponent is one step down of what the operation is going on with these monomials. So if I'm multiplying the monomials, then I'm going to add the exponents as long as I have the like base. Okay, these have two different bases, so I can't do that. And also I'm raising it to a power. So if I'm raising to a power, the step down, what I do with the exponent is just multiplying. Okay, and likewise the division, I subtract the exponents. Right, it's kind of one step down because division is just repeated subtraction. So it kind of works out. There is a long way to, you know, explain all this from scratch, but if it's been a while for you and you want to have more videos on like the basics of that, then I can send you something on that too. Just email me. Have a great day.